Let's go over some problems to help prepare for the 2.5 to 2.6 quiz. On this quiz, you will need to graph and write equations of piecewise functions, graph and write equations of absolute value functions, and you will need to be able to graph and write equations of linear inequalities. So let's take a look at this first one. It's a piecewise function. And what we need to do is we need to graph three functions in their three different sections. So this is h of x equals, and then our first one is x minus 3. So when we see that, it's really like h of x equals x minus 3 or y equals x minus 3. So we're going to graph that, y equals x minus 3. So we start at negative 3 on the y-axis. Our slope is 1, so we can think up 1, right 1, or down 1, left 1. And there is the graph of that line. Now, the next part, this part right here, tells us we only want this line when x is less than or equal to negative 1. So that line should only be when x is less than or equal to negative 1. So to the left of this. So we are going to erase everything up till negative 1. And so here's negative 1. The x value is negative 1. We're not looking at the y value. It's the x value is negative 1. It's or equal to, so it's going to be a closed circle. And so that's the graph that we want right there for that part. Let's move on to the next section. This is just y equals 1. We know y equals a constant is simply a horizontal line. It's a horizontal line, so we're going to go y equals 1. Well, y equals 1 is up here. There's y equals 1. And we only want that, once again, it's got this interval that we want to graph from x is negative 1 up to x is 3. Both inequalities do not have the or equal to. So we want to go and erase. And we want to keep from negative 1 up to 3. And we put open circles on both ends there. Oops. And then our last part is to graph y equals negative 5. And we want to graph that just when x is greater than or equal to 3. So we can, for these first two, I graph them and erase them, but we can think ahead and we can just graph this when x is greater than 3. So here's 3. So we want to graph to the right of that, and we want our y value to be negative 5. So we can put a circle here. And there's the graph of that line. It is or equal to, so we want to fill in this circle. So that's how you graph that piecewise function. Moving on to the next one, absolute value function. We should know that just the parent function, y equals the absolute value of x, is a v. The vertex goes through 0, 0. The right side has a slope of 1, and to the left of the vertex has a slope of negative 1. And we learned that adding or subtracting inside the absolute value will move this left or right. It actually moves left if it's a positive number, and it moves right if a negative number. And then adding out here, this moves it up if positive and down if negative. And so with this one is going to move right because it's negative, so right 4, and since this is positive, it's going to be up 1. And so our normal vertex is at 0, 0, but this is going to move right 4 and up 1. So it's going to move to this spot right here. And we're going to have that V shape. The right side is going to have a slope of 1. This left side is going to have a slope of -1. And there is the graph of that absolute value equation. All right, moving on to writing equations. We're going to first write the equation of this piece function. This one has 3 pieces to it. And so we can say y equals or f of x or whatever we want to use. So let's say f of x equals, and we're going to have 3 sections. Trying to give enough room there. So let's kind of color code this again. Here's our red one. What is the graph of that line? Well, that is a horizontal line. So we know it's just y equals a number. So f of x equals, and this is 3. So 3. And then we have to put the domain for this section, this red section. So this one is from -4 to 2. The way that we do that is we put -4, we put our lowest x value, we use less than signs, so this one's a less than or equal to because it was filled in, x, which is just less than, it's not filled in, so which is less than -2. And that's our first section. Next, let's look at this other one, which is green. Now this is not a horizontal line, so it's going to be in y equals mx plus b form. So y equals mx plus b. And we want to think through this. The slope. Do we have the slope? Well, we can easily find that. We do rise over run. So we pick one point. So let's start with this point. We go down 1. So that's a -1 and right 2 over 2. And then b is simply the y-intercept, and that is 3. So our equation is y equals -1/2 x plus 3. So that goes here in our piecewise function, -1/2 x plus 3. And now we need to state the domain for that section, and that is from -2 to 0. So we know we have -2 is less than or equal to. We put the or equal to because the circle is filled in. X, which is less than or equal to 0. It goes up to 0. And we're thinking x-axis. And then our last section, this blue section, I won't trace over because it's already blue. Once again, it's not a horizontal line, so we want to do y equals mx plus b. We want to find the slope. So let's find a couple convenient points. Here's one here, and then all the way up here is another one. So we can use that to find the slope. That's rise of 1, 2, 3. I'm just going to put it right in the equation. And a run of 1, 2, 3, 4. So 3/4 x plus b. B is the y-intercept, which is, I know I scribbled over it, but it's -3 there. So we actually could, instead of putting plus, we can just put -3. And that is that equation, so 3/4 x minus 3. If, and this one goes from 0 up to 4. And before I colored all this in, this was an open circle here. So just is less than x. And then our furthest, our furthest to the right point, I said that wrong earlier, is 5. We go by the x value. So the furthest to the right it gets is 5. So less than or equal to 5. And there is the equation of that piecewise function. Next one, we want to write an equation of this. We see it's a v, so it's an absolute value equation. So what we can do, we see that it's not at the vertex, it's moved left and it's moved up, so we're going to have to change some things in here. So it's going to be x, it's moved left 3, and so we remember if it's left, we have to put a plus 3, and it's moved up 2, so moving up is adding 2. And we know that from what we mentioned up here before. Our last couple questions are graphing inequalities. Our first one is in y equals mx plus b form, or it's not equals, it's greater than, but it's in slope-intercept form. So we start with the 4, we start with the y-intercept, then we use our slope. Now this negative here can go to the top or it can go to the bottom, but it does not go to both. So we can write it as -1/3 or 1/-3. We cannot write it as -1/-3 because a negative over negative is positive. So we do not do that. So using this idea, we can go down 1 and right 3. Could do that a couple times. Or using this idea, we could go up 1 and left 3. And when we graph this, we have to remember a couple things. It does not have the or equal to, so we want to put a dashed line here. This means that our answers do not include this line. They will only include the shaded part. And then when we shade, it's greater than, so greater than we shade above the graph, and less than we would shade below it. But this is a greater than, so we are going to shade above this graph. And so all those points in that shaded section, except where I accidentally went over the line, are solutions to that inequality. And our last one we want to graph is in standard form, so we want to switch it to slope-intercept form, which means we want to solve for y. So I'm just going to come to the right here and do this. 3x minus 4y equals 12. We want to solve for y, so we subtract 3x from both sides. And we get -4y equals -3x plus 12. And dividing both sides by -4. Actually, I made a mistake here. This is not equals, this is greater than or equal to. So greater than or equal to. That was bad. We want to divide both sides or each term by -4. When we divide by a negative, we have to switch the direction of the sign. So this greater than or equal to becomes a less than or equal to. -3x over -4, that's the same, that's a negative over a negative, so a positive 3/4. We can write the x out here, and then 12 divided by -4 is -3. And so our line goes through -3 on the y-axis and has a slope of 3/4, so we can go up 3 and right 4. We could do that again. We also could go down 3 and left 4, and that should give us a good, pretty accurate spot for our line. We use a solid line because it had the or equal to, and it's a less than, so we shade below. So shade below. And so the points that make this inequality true are the points on the line and all the points in the shaded section. So there is a review for your 2.5 to 2.6 quiz.